And without further ado, I had the pleasure of meeting with Mitch, probably, I guess it was 9 months ago. I'm a big Frank Gehry fan. For those of you who don't know, he has these incredibly beautiful buildings that have gone up. And we saw that Frank Gehry had this joint venture with MIT to develop the car of the future. Now, I'm not sure if Frank Gehry has actually pulled his share of the weight, but MIT has done a lot of work, and I called up Mitch and I said, we'd love to see this. And Mitch took me through these incredible slides that were so creative. I got really excited. So without further ado, let me pass it over to Mitch.
Okay. Thanks, Allison, and the Alternative Wheels Festival, or Alt Wheels, for having me. I'm going to give a talk on eco-transology. It's essentially a lot of the work that we did at the Smart Cities group at the MIT Media Lab. I just graduated with my doctorates there, and I'm back in New York, but I came up here to do this talk because I hear there's a lot of like-minded people thinking about ecology and the environment as it relates to transportation. So we've got about, I think, 40 minutes of a talk here, and then I'll have some time for questions, and I hope you have a lot of questions, or at least challenges maybe. Because what we were doing is slightly controversial. We started off thinking or rethinking the car with Frank Gehry, and General Motors was our sponsor. But then it came down to, well, it wasn't just about vehicles, it was about advancing human mobility in cities, which is a much larger thought, and dealing with the global energy crises, which is a big initiative at MIT. And it didn't come from one discipline group. It needed the whole group together to kind of solve such a large-scale problem. So the thesis was ultimately, what would be this new field of study that would encompass various disparate disciplines and groups and fields of knowledge that would make one field of knowledge that would help deal with the global energy crisis, particularly within circuity and transportation. So these series of slides here unpack the history or some of the earlier visions of this, because I think this has been in the hearts and minds of people for, at least since the birth of the car. And the second part is actual car designs, more or less, and they're not styles. They're rethinking the car from the very wheel itself to the from the drivetrain to the envelope to every facet structurally of the vehicle. And then the third part is about how we can really integrate them into cities. One of the things that I should start getting into this. One of the things that I do is I'm an architect and an urban designer. I also do landscape ecology, and I guess now transportation. And it's really important to be candid up front. When I started this, I knew absolutely nothing about cars. In fact, I still don't think I know anything about cars in the traditional sense. I couldn't tell the difference between a Mazda and a Toyota. I'm from New York. I've always taken trains or subways. And now that I'm back in New York, I'm back to trains and subways and sold my Honda. But I guess I came in with the eco-minded perspective, and there are a lot of other guys in the group, about 14 of us, really fantastic individuals that knew a lot about cars. So it was kind of a good point of contention for me to come in and say, well, how does this equate to something like mass transit systems? We had the group was comprised of essentially there was a medical doctor on the team, aerospace engineer guy, computer scientist, a couple of other wonderful engineers, a lawyer, and it was about all of us working under Bill Mitchell in the Smart Cities group to rethink the vehicle. So this is the beginning of this burgeoning field that we're calling transology or eco-transology, which describes patterns of mobility. These are some of the fields and the contexts which these fields operate in. So there's this Venn diagram that's kind of showing some of the relationships of making this into one primordial soup of thought. And these are the four parts that I've just gone over that I'm going to discuss. First part being the history or the ideation or the visioning of future cities. And then into the eco, which is really thinking about architecture and sustainability in buildings. And then transportation, then eco-trans. So let's get into the first part, ideation, which is divided up into a series of challenges, archetypes, infrastructures, and deployable spaces. And finally, our own suppositions on smart mobility, or theories on smart mobility in the cities. especially using technologies that have been around the Media Lab for some time. So the biggest issue we had to deal with was, well, we looked at energy use in the United States, and these are facts you can get from the U.S. Congressional Budget Office and transportation, dealing with the transportation sector. Specifically, we divided up into industrial, commercial, residential, but transport here is 29% of the suck of energy in the United States. This is expected to double as a common statistic. What we were looking at specifically was intelligence to deal with something like circuity, which is, well, some of you must know that, but just for the sake of this talk, circuity is getting lost, looking for parking, poor navigation, driving around, just not going anywhere. Instead of getting from A to B, you go from A to B to C to D to E. Eventually, you get there. It wastes a lot of energy. So what we could do with the Media Lab is we can make vehicles smart. And exactly how we're going to do that, I'll unpack that. But that was the big challenge. So here's one of the precedents in the ideation phase, which is way back in 1908, Harry Pettit had, and King's Dream of New York, a developer, thinking of these super clusters, dense residential districts and commercial areas that were all about, the future of mobility. Future of mobility not only on the exterior. You could see somewhere the bridges over the East River. There's 4 bridges there. Today there's maybe 1. But it's almost like a hypermobility, bridges between elevator cores and clusters of buildings. And then this canyonated system down here where you can see the pedestrians and horses and carriages and cars at multi-levels and tiers. And, these fantasies, since they've been around for a century, well, what does it take, right, to make some of these things reach fruition? A lot of stuff I do in city theory has also been around for some time. One of the greatest thinkers we do need to give credit to is Patrick Gehry's in the Valley section, where his position was that the first road, right, the first effective road, especially for freight transportation, was rivers in the world. But most cities are designed around rivers and pathways. So here he's talking about the interfaces of human operations, actors and agents on the landscape, cut through a section of a river from the mountainside all the way to the edge of a lake, for instance. And this becomes important later because we've decided to rethink that interface. Here we're thinking of the pickaxe for the miner or the axe for the woodsman or fishermen with their fishing rods. But what are the transportation interfaces that affect cities and affect the landscape? These are some other visions. Edgar Chamberlain in 1910 thinking of these munificent road towns. Corbett, a congestion engineer, I guess he was a Columbia prof, really fantastic guy. Also thinking about infrastructure in relationship to bridging, tall buildings, and transportation. His diachronic drawing here showing sections of how the city would develop or evolve over time to deal with congestion, transportation, separate pedestrian use, and then carve into the architecture to supply places for safe passage for people and families and have places for fast mobility, slow mobility, and storage for parking. Sant'Elia, big movements in the art world. Futurists, especially, this is one of the best. This new city, as he was calling it, here made a spectacle of mobility, where he extruded elevatoring systems outside of the cores of the building and obviated them into the architecture. Other views are a little bit more maybe Nazi-like, with this endless repeating 100-story towers and grand boulevards above them and civic spaces inside it, and then marching along is this canyonated series of just congested vehicles moving in and out. I think this is basically the precursor to the BQE. And then a great transologist, Eisenhower, back when he was a lieutenant colonel, and his contribution, especially to U.S. transportation. Some of you may or may not know about this, but he was certainly a thinker about mobility in the United States. And even today we think of red and purple states and how he separated them. It started back in 1919 in his transcontinental motor convoy, where essentially as a military act, a war game, he said, well, what if we had to go from, D.C. to San Francisco to defend the United States of America? Well, is there a road system that can do that? So here he is trudging through the mud trying to show that, through moving tanks, or, well, they didn't have tanks, but jeeps and armored vehicles and soldiers, it would take months to get across the United States to defend it. This ultimately led to an act of Congress to establish the American highway system, especially after seeing what the Germans could do in World War I and II with the Autobahn versus rails. If you knocked out a section of the Autobahn, right, the Germans were running on it the next day or in hours. It was easy to repair a highway, as opposed to a rail system, which if you knocked out a rail system, supplies would be cut off for a long time. So the highways in the United States were started as pretty much an emergency act of war to protect us. It's kind of a well-known fact, but maybe some don't know this. Other issues of advancing human mobility come from the actual, directly to the individual self and the interface with the sidewalk, things like moving platforms, escalators. We didn't discount these things, but we concentrated essentially in vehicles. But here are things like moving sidewalks in ribbons of speed, so you'd have on-the-fly transport and always have the city alive and moving and seeping and oozing. These were proposed in Atlanta. And then bridges themselves becoming architecture and urban design. Here's housing built into bridge systems. This is a kind of an interesting view of Manhattan, Raymond Hood, thinking of this clusters of skyscrapers connected and bridged, and then Manhattan also bridged, hyper-bridged with housing built into the transportation. So, exactly who would be responsible for designing a piece of infrastructure that's architecture, of public housing, deals with multi-levels of mobility from trains to cars to pedestrians. It's been a problem for 100 years. And of course, Norman Bell Gates in Futurama, another view of the future. And Hilbesheimer, escaping Nazi Germany, and his view of what we could do with Manhattan based on transportation. So here he is. I kind of love this sketch because of the chutzpah involved. He's wiping out Manhattan and replacing it with a big transportation node and then dotting slabs of housing in the center. Great. So when does this become interesting? Well, when you deal with a calamity like New Orleans, where the city is wiped out, and you have to rethink most of the city, how do you create a pedagogy, or who's prepared to really redesign it? It's usually groups of people getting together, but I think this is something that could happen at the academic level first. Today we do a lot of incremental phasing, and urban design is project-based. It's not entirely city-based. So that would be an example of let's start from scratch or degree zero city design. Louis Kahn in Philadelphia, thinking of clusters of skyscrapers or tall buildings and housing combined with parking and mobility. So architects have been thinking about this. Landscape architects, Jellicoe's Motopia. Here are these nodes across a matscape, or just the land is in the switch fabric between civic places and housing and then mobility. So you basically, cars move above and you dwell underneath. Archigram, one of my favorite groups for the 60s, they were thinking about, well, let's just have cities themselves be mobile, or walking cities, and many other iterations of that. Solari's Arcology. This guy's making mud pies in the Arizona desert, but he was certainly thinking about this miniaturization of the city into this very compact notion of infrastructure and dwelling. Paul Rudolph, thinking of the Lower Manhattan Expressway. In this case, these topologies, and there's many others like it, but I'll use this one as examples, about the spine. So development along the spine that accounts for orientation, light, air, and then transportation underneath, slow motion transportation, local transportation, then fast moving transportation from region center to region center, and then, of course, in the background, clusters of skyscrapers connected. And, Goldberg's Marina City is the architecture-like project. There's a better picture where it shows the marina underneath it, so you have multimodal boats and cars and people dwelling all in one place. This is kind of fascinating in my studies on skyscrapers. One of the concerns was what's the tallest occupiable balcony you can have in the United States. To make a building really green, natural ventilation is really important. So transitions in the facade are paramount. So I was looking for what's the highest you can have a building based on the bodily physiognomy, based on what wind loads we can really tolerate. So here at about 63 stories, you have occupiable balconies in this project, and that was mostly due to the fact that you're stacked on top of cars. I don't recommend living the 63rd story and having a balcony, especially in America's windy city. Here's the Nervi, a phenomenal engineer, a formalist, and also thinking of spines in the city. And this one built. This is a bus station, GW bus station in Manhattan, where it goes from the George Washington Bridge to this, this great ring of highways to the multimodal station, and then in the background, clusters of tall buildings, all connected to mobility. And other thoughts about miniaturization and separating storage and the drivetrain and separating cars for suburbia and cars for downtown cores. So these series of diagrams unpack storage and passenger space, and then we start thinking about, well, we should probably focus in the downtown, because we can't solve all the problems right now. But this is basically the earlier case study for the vehicle that I'll be showing you shortly is mostly for urban cores. And this is probably, this diagram has been around for some time, I think in the circa 1960 something. So this is showing you that we've been thinking about this for a while, and actually we reached it to the point where we're building it. And thinking about also intelligent storage of the vehicle itself, robotic parking systems, and robotic systems where the elevator and the car bleed into one. In this case is a trans car system. The hospitals use them, but they're leaving the core, right? The elevator core. They're leaving the realm of the circulatory space in the building, and they travel throughout the building and then go back in it. As a kid, I was always fascinated on Star Trek on how they possibly navigated through, in these elevators through the Enterprise, as it clearly wasn't a vertical shaft, but maybe it was something like one of these transcar devices, so you're actually traveling through the floor space on one of these robotic elevators. And how can we get rid of clanky metal boxes and just this chainsaw to cut butter mentality? So much energy is wasted in producing a vehicle like this. The elevator itself is a really elegant system, especially from a physics perspective, right? You pay some energy to go up, but the counterweight gives it to you back when you go down. So elevators become super important. I'll show some of that later. And then thinking of switch fabrics in highways, here zipper machines can switch lanes and switch the directionality of lanes. And dealing with purchasing goods, so it's not just for moving people, but for freight. And some of these chainsaw to cut butter devices, escalators for your shopping cart is kind of wasteful, decadent, but I sometimes appreciated. I'm shopping in Crate and Barrel recently for. Anyway, Michael Webb, thinking of a space that bleeds, or the car itself becomes an architecture. He was an archigram member. Here, the car becomes a bathroom or a water closet, and then becomes a bed, and then shrinks back into its, I guess this is a Lamborghini, someone might know, and then it zooms away. And other variations on that theme where the cabin leaves the realm of the propulsion of the vehicle and enters the space, for instance, of an apartment system that's also on rails. This was Takahiko, professor at MIT. I had worked with Michael Webb on some of these animations. NL architects, these individuals thought of the very topology of the building itself would be influenced by parking and transportation, or basically the car itself would form the architecture, so the other way around. And Louis Tomersky Lewis, where you got to look a little bit carefully in this image, but in the interstitial spaces, you have vehicle parking, and then you have your offices above it where you work. From an efficiency standpoint, this is not so great, but it's a little bit different when you start interleaving the parking program with occupiable floor plate into the building itself, as opposed to the Marina Towers, which divides it in half, parking below and dwelling above. It's kind of curious. And then finally, some of these other fantastic visions. I didn't know if I liked Tom Cruise in the movie, but I certainly like the visions of thinking of these magnetic levitation strips that had apparently no gravity, and your apartments are part of your car, and your car is a part of the city, and the city is car, and car, city, apartments all bleed into one. And it gave us some really good questions about cities have been designed around vehicles, at least modern cities. And before that, they were designed around horses. So how we design the car around a city. Road ecology, Richard Foreman, a professor of mine at the GSD, was a phenomenal influence in thinking about the vehicle and what its effects on the road. I think road ecology as a discipline is super, super important, would be also part of this pedagogy. Here in this chart, you can see disturbance, for instance, in bird populations in the distance from a highway. I think it's 1,000 feet. Birds will not nest, which is a pretty impactful note. Okay, so now it's enough of the history. Let's get into some smart mobility and our suppositions that we were thinking about with what we can do to the car. So we have a dictum. Right here is its form follows frequency. So it's not necessarily that it takes on an actual image, right? Because a lot of the intelligence is invisible. It's networks and it's net wheels and it's a municipal grid and GPS and a lot of electronic signals talking. And then the city comes after these vehicles have talked with each other. So this became an overriding axiom or bromide into most of the project's work. We thought basically the car is really not so important. We thought computers were more important. So I think we've decided that, well, what if you think of the vehicle as really just a very large, intelligent computer, and just it was mobile, not unlike a laptop. So we did some scales and orders of magnitude of the intelligence you could possibly get in your vehicle. So here you start with something like a key. And when you merge a key with some level of computation, you get an RFID tag, for instance. Or when you have a telephone with a medium level of computation, you get a PDA. And a suitcase with a large level of computation, you get the laptop. Well, what's bigger than a laptop and that's mobile? Or they think, well, it's a car. Certainly the car could be, especially with display capabilities alone, you can have just a phenomenal amount of computation in a vehicle. And computation that's updatable and something that you can, you can change it over time. So we think of these big, soft, super smart vehicles that are more computers than they are cars. Well, these images probably won't work on a Mac, but here we're thinking of the social posturing of the vehicle. So if you just bear with me as I zip through, QuickTime. Some of the things that the skin can provide for the car. So e-ink and organic LEDs would do some of these things like social projection. So you'd have the cars, you can display something on the outside, the Red Sox rule or, whatever. But when you start thinking of a field of these cars, you need human communication as well as vehicle-to-vehicle communication. Back into it. Great. And thinking of not only the vehicle itself, but the entire informatic of the cityscape becomes one. So it's not just a veneer, an intelligent veneer, but there actually gets solid and intelligent and actuated systems that are all speaking and talking in this future city. So here's a kind of this is a part of Chicago that had been rethought of as all super hyper informatic. And then shading systems and aperture systems built into the skin of this soft car. It's probably not going to play again. No. Well, what you saw briefly was basically you can have a visor that would track the sun to deal with some environmental concerns, stop shading, or the skin can be completely opaque and transparent following the viewer's line of sight. And now we get into the interface of the vehicle itself. So this matrix takes some time to absorb, and I'm not going to unpack every inch of it, but it's basically the history of the city versus mobility. Or not versus, but aligned with mobility. We're calling it TUI, similar to a GUI, like a mouse and a keyboard or graphical user interface. This is a transportation user interface, and it starts from the foot and the hoof and the wheel, things that influence the shape and the form of cities and urbanization and pretty much the world. And our supposition is pretty much around after the rail, and we're calling it the net wheel. or networked wheels. We decided the car really, we thought of rethinking the wheel. We put the entire solution space of the car, drivetrain, suspension, motoring, intelligence, everything happens in the wheel. And then you just add an envelope. And then you add wheels to each other. And these wheels talk, and they're smarter than people at some level. If I walked 5 blocks down and made a right, what's the name of that street? And is there a pothole there? Unless you've walked it every day, you wouldn't know that. But if wheels are talking and they're connecting to a municipal grid and they're constantly re-recording the cartography of the space, the urban space, they would know something like that. They can warn wheels ahead of them. There's a pothole there. Don't go there, etc. So there's range issues and speed issues. So this is similar to the earlier precedent by Gehry, the great urban thinker, thinking of city form in relationship to the landscape section, landscape ecology, and then the mobility interface increasing in range. And it's intentionally, ideal, but the point is to, to show you in a simplified form where we're thinking this future city is operating. So you can see on the top, the foot makes a very smaller scale city. You can't bring lots of supplies by foot. The hoof, larger but still intimate, a nice, comfortable city. I think people like these kind of cities today. Then here comes the wheel. Cities designed around the wheel are much larger and not so comfortable, canyoned spaces, and rail cities the same way. And then the net wheel, which is this intelligent, super-connected city. And we're thinking this operates in the city core, downtown between industrial areas, post-settled areas, to edge areas, and that there'd be a linked system that would bring us into the 3D, or the vertical axis, Z mobility. So this image, one of my takes on the soft car would be future mobility with these omnidirectional, super intelligent wheels, and linked to other vehicles that are talking and charged in these charging stations that would use renewables. And you can imagine oozing in a stream of these vehicles that are socially projecting to one another. We're tired of the precious metal box, right? Don't touch my car, don't scratch my car, don't look at me in my car type vehicle. Here we're saying it's a gentle congestion, touch, bump, rub, soft, it's okay, because we're going to get there faster and traffic is attenuated. And, you can think of it as moving in like a bloodstream, ooze with passengers seeping in, seeping out, and this film probably won't work. Oh, there it is. So you can imagine mobility like this in the future with these soft cars. So we had to go and build it. So we started with the wheel and getting to the skin. Let's see some of that. This is showing it phasing into the city. So, a lot of questions I get is blah, 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 softer cars. Well, we're already there. When you introduce something that's hard into the system, something that doesn't even have a crumple zone, barely, like a Hummer, which is this precious, super strong, metal, impervious box, you make everything else softer in the city. So you're kind of doing that already. And, these vehicles are certainly, I think the reason for a Hummer is that you buy one for your wife, supposedly, so that when she gets into an accident, she kills everyone around her, but she's safe. So this is this kind of view of phasing softer, gentler, sheep-like cars into a city and dealing with things like Hummers that we know will take them out rather quickly. But speed, again, is a factor. We're moving much slower in these cars. Doesn't need to go faster than 30 miles an hour in a downtown core. That's a shared ownership model. But I should probably show this video. Well, here's saying what it's going to replace, which is command signals, gradient changes in curbs, light switches, all of these things that we're psychologically prone to following orders to. There's no real reason to stop at a light. We just think we're going to get killed, but nothing really stops us. So what if the cars really do stop you? And then this is a car designed around the city, and then the city changes to readapt itself to a car that's adapting to it. So there's constantly an exchange. Moving from regional center to regional center. This is looking at kind of critical moments between tall building clusters, accounting for light and air, and then transportation. I've got to come back to that one in a bit, and a city based on that influence. So here's the beginning work on the wheel and its omnidirectional capability and its z-axis capability. So you can see that it moves, it spins on a dime, laterally forward. It's talking to each other. It's based on the GM skate that's been modified and cut up and made a little bit smaller. I think the powertrain for this was a fuel cell. And then the wheels can clasp onto rails and engage facades. And you'd have both passenger and freight transit inside these systems. And we're thinking that, well, it's influencing the city, right? So they're sticking to buildings, gliding over. Buildings are bridging. Vehicles are bridging. So here's a first sketch of that. Well, what exactly does that do to a skyscraper, right? So it took a year of research at Moshe Safdie and Associates, really great firm here in Boston, where we started looking at tall buildings and, more importantly, questions that we didn't really have answers to, which is clusters of tall buildings. And that came really down to relationships, ecological relationships between cores, elevator systems, and skin, and then bridging ultimately. So here's this supposition of the city of bits, all of these vehicles fitting into the city, moving up cores, fast sections for fast transit just through the basement levels, massive charging stations, floor plate stacking and bridging. There's a lot of benefits to bridging tall buildings, which I'll show later. And the buildings themselves becoming actually mobile and sections leaving the building core. So how can we do that? Because we want the building itself also to be mobile. So here it is kind of fragmenting up. So let's get into the eco part of the architectural area and then into the cars themselves. So this is just 3 quick projects I'll show you that I've been working on to think of the 100% really sustainable or ecological architecture. This one, the first project is called the Fab Tree Hab, which is about pleaching inosculate matter or grafted sections of trees to grow superstructures for housing. The notion here is that sustainability as a philosophy is a little bit too status quo. How do I put this? You don't want your marriage to be sustainable. You don't want your relationship to be sustainable. You don't want really anything to be sustainable. It means just getting you through the next moments or even a couple of moments beyond that. But it's not evolving, changing, living, loving, growing. There's always at some point you need to think of this, the evolutionary aspect. So I'm thinking more of an ecological architecture, which is different from the sustainable philosophy. Ecology is a science, and here it's a science of horticulture and botany. This has been around since before Rome, and they're growing trees together to form shapes. Part of the work I've done at MIT was on CNC-controlled geometries, basically printing out complex geometries and marrying it to the idea of living systems or pleaching systems that we've been using in gardening since before Rome. Grafting trees happens in fencing. So this is a notion of an entire community that's actually 100% living. No felled timber, processed industrial timber, or even transport to bring building products to the site would be involved. This is 100% view of the future that's holistic and ecological. It takes some time to grow, and there's some talk about genetic modification. I certainly believe in the scientific precautionary principle, which is let's not modify every tree we can so we can speed the growth and build tons of housing for millions of people. But you can think of the agricultural precedents that are already there, such as tree farming for Christmas trees. You can set up a farm that will pre-grow your village. In about 5 years' time, you do have some habitable spaces. With controlled geometry, you can set up jigs, right? That would create a tightness in the structure, force the trees to grow where you'd want them to grow, to be waterproof. No joke. So we have a company in the Negev in Israel that does this. So we do CNC models that create jigs, and we grow ficus through them, and we get this structure. There's this wall section through there. It might not be relevant to everyone. Agricultural products and cars, so thinking of the fully organic vehicle. And, I'll leave out the other projects. I think I realized it was going to be a talk on cars, not architecture. So let's get into the trans. Trans is this super soft ecological car. And thinking of in a series of steps from human-powered vehicles to lamb cars to pneumatic cars to rethinking the structure of the car itself. The semiotic pulse of something like the soft car. like I said, where it's a statement against these precious shiny metal fancy cars. I think that our society today has some clear inputs on what is beautiful and what's not. So we've kind of taken the antithesis approach to thinking of what's comfortable with me: soft, fluffy, fat cars. And a quick note about Henry Ford. This is not unique. Henry Ford was growing cars, right? He plants seeds and was growing cars just like I would like to plant seeds and grow houses. He was thinking of doing this with soybeans, right? Back in the day, and this vehicle kind of shows it, he wanted to merge America's agricultural economy with our industrial automobile economy. So we would grow plastics, right, that would make car bodies. And here he is hitting a soy-bodied plastic vehicle with an axe, and it sort of bounces off, and more or less it's an edible car. So I kind of really appreciate Ford for that. So we're thinking of the same super ecological edible skins for the cabins of the car, and the wheels themselves would be the necessary electronics and propulsion that move them about the city. So here's a couple of iterations of these cars in a city someplace. Thanks to the Mac, the graphics are slightly off, but the Sustainable Omniflow Transport, SOFT, that's what we decided to name it. I'm not an advocate for sustainable, but the group thought that would work. And by making the car soft, I think a key statistic, because we're all fascinated by them, is that you can reduce 44% of the mass of the entire vehicle if you rethink the body to make it as lightweight as possible. So if you think of the overall life cycle of this car, it's 44% less weight. So it's less bad. Less bad doesn't mean more good. You're still doing something bad, but we're definitely making the car as lightweight as possible. So thinking of these super soft, informatic skins. In this case, it's made up of quilted ETFE pillows with embedded electronics, some starch foams that support this car, various parts, and then an internal safety cell that would not be edible. It would have to be something like aluminum to absorb impacts. But that helps keep the skin in tension. And thinking of the car as a series of, it's just air, right? It's all soft. It's an air quilt, and then the seats are air bladders, and with 6 points of safety with airbags. And we know the benefits and constraints of airbags, but it was one early iteration. And there's probably 50 or 60 iterations of this soft car. And I think the latest version is ready to roll out in November. So I don't have the final to show you, but we will soon enough. This is a section through these ETFE quilts, then embedding smart geometry in the quilts to give them more stiffness and structure, and transfer of low pressure of air between quilt to quilt from microcompressors on the car. And the Lamb car is another view of the super soft car of the future with brush wheels. I think the idea would be it's okay if you can roll over children like a Nerf car. It couldn't possibly hurt you. I think a lot of these things that we were saying and doing you get fired for if you worked at General Motors. But we did really say these things and do these things. And instead of car refinement, we just rethought the car on base humanistic principles. Like no one will ever die in a car accident again, not on our watch. Another version of the soft car. In this case, we thought of a super safety mechanism called the friction belly, right? So here you think of the contact patches of the wheels. There's just those little points there. But when, let's say, at some point you've lost control or about to be in an accident, the entire belly of the vehicle increases the friction on the road to slow the vehicle down. So you can see the difference between those. And then cars that expand and contract with these soft skins. Here's an Exodillo version. Now, Frank Gehry I was working at the office in L.A. as an architect for a cluster of skyscrapers in Brooklyn called Atlantic Yards. But for this project, which I starred on, he was the kind of the lead author and designer in the beginning. And at some point, there was an argument of design fees. So, I don't know where he stands on that. But in this version, and in many versions, he had some really brief comments about what he thought. He said this one looked like Nemo's submarine. Get rid of it. So we got rid of it. There's a 3D print of Nemo's expandable submarine. And here you can see a close-up. This was for Popular Science of the wheels with the suspension. It's basically a hubless wheel with all the car we can fit inside it. And another version. that vehicle. And things about the structure in relationship to accidents and dynamic cabins. We had a young physicist in the group, this 18-year-old whiz kid, Louis Basel, who said, hey, we got to rethink the physics of the car, especially in accidents. We absorb a lot of impact and velocity in crumple zones. Well, what if the cabin was dynamic and moved within the line of force of the body, the human body? And the doctor was like, well, that's a good idea. Let's think about it. So I started these drawings of rethinking the structure of the car, which is essentially a brick on wheels, and thought of a suspended cabin from one particular pivot point in a wishbone-like truss system. So we just hang your car on its wheels in this truss, and you have the ability to, like the soft egg inside, can move in any direction with the same vector of force of the impact. So the initial impact, you move with that line of force. And this became what we call the soft bone car with an added hook for storage. Essentially, it's the same kind of soft cabin, suspended though from a wishbone structure, and there's a safety cell around it, of course. And then, we got tired of this continuous aesthetics of softness and what would be a self-healing fabric for the cabin of the car. So rethinking the overall aesthetics of matte cars or soft cars that would be similar to like sneakers. So here I went through a series of iterations of thinking of these like quilted kind of car patterns that are okay to scuff, okay to rub up against. Here's a pneumatic tube version. The windshield and the windshield wiper. For those of you who are car designers or engineers, pretty much in most of transportation, will know that the holy grail of engineering design in transportation is the windshield wiper. If you can think of a better solution for that, that will deal with all sorts of weather conditions. I mean, it's in the space shuttle, the Concorde, and every vehicle. Great, let me know. The windshield and 50 years of doctoral study on windshield safety glass and everything pretty much made that one point of the car hard to change. And we certainly looked at a lot of technologies. But besides the windshield, the rest of the vehicle is super soft. And we were in line with Reebok, who came by as another sponsor of the lab. So thinking of, let's make sneaker cars. What are those guys doing with the fancy sneaker technology we're purchasing every other year or so? And how do they do that? And, I don't know, car guy, like the most sneaker car designs I've seen are basically they take the look of a sneaker and they make it into a car where they style it. We weren't concerned about style. It was material, softness, and scuffability, and economics. They're cheap. So why not have a cabin you can, turn over every couple of years, made out of sneaker-like material with the same sneaker-like aesthetics and stitching and materials. So you have a zipper door. You get in and out with a zipper. I really love that one. And then another model where the shoehorn was the seat that stretched the rest of the envelope of the car. So this is a three-wheeled vehicle that does that, omnidirectional. Of course, all of these are omnidirectional. And then really getting the footprint of that vehicle down. So here's a planimetric view cut showing the section of this cabin in this future car that's a wireless drive-by-wire, omnidirectional, networked wheel vehicle made out of sneaker-like skin. And, impossible fantasies of shape memory alloys, thinking of what's the smallest footprint we can get of these sneaker cars? And here just one layer would memorize the contours of the body, and then when you want to store it, the entire car folds up. And how does it support itself? Well, it's intelligent tensioning between the wheels, keep the skin stiff. And thinking of even smaller footprints, which is standing. So, this is the car for downtown. It's, kind of like an iPod car, cell phone car. It's a leapfrog technology. Cell phones have changed a lot. So we think of, I'd like just to get to some place and not have to worry about my transportation at all. So here's this kind of standing or somewhat squatting car. The reason for that is that, it's the smallest possible footprint in plan the body can make. As opposed to standing, it's actually, if you look at a drawing, there's more protrusions. So this is hiding your feet, which normally stick out depending on the proportion of your body. These are these I-stand vehicles also on the same tensioning between intelligent omnidirectional wheels that are networked and stacked. Here they are, stacking part. I should show you some of these, I will show you some of these iterations of the stacked car. I can get to it here. Here's some. Nope. Well, this is This is the wheel technology. I think this is Peter. So here you can see one of our wheels. I think it's Louise is riding it. So basically the whole vehicle is in the wheel, and then we just have a battery that he sits on top of and a bicycle wheel. So this is one wheel that would be added to 4 wheels, and he's not wearing a safety helmet, and we're just speeding around the media lab. This is showing he was still. This, I think, was the second iteration. Each one we've been patenting. There's the wheel car zipping around. And so now I'll show you with its robotic arm extension, thinking of the wheel as this intelligent kind of robot. I'm used to seeing these things actually have small. Let's see what this one is. Yes, it's the future car. I don't know what's going on. Yeah, this is brilliant. As you can see, it's great. Maybe the patent isn't finished, so we can't show you that. We'll show you something else. I got a lot of nifty movies from inside the project that I think you guys will find kind of cool. Great. I'll click that off. And let's get to this one. This will come up. Okay, so this is another view of the stackable city car. So here we have, this is Will in the car. Franco was involved in making this movie. And he gets out of his car, and he takes some of his stuff. And the car's preset to his size and the music he likes and where he likes to go. These vehicles are all driven by navigation, and they're wireless. It's not a steering wheel thing. They're intelligent, and they talk to one another, and they articulate. So the frame raises for maximizing its storage capacity. The next one comes up to it, and it interlocks, and Suzanne gets out, and it's preset for her needs and the music she likes and the places she likes to go to. And the car stacks, and it's charging now. And it's charging in a stack, and along comes the next vehicle, and so gets out, and you have all of these cars, and you go, well, how do I get back into my car? Well, the good thing is that it's a shared user relationship. It's only for downtown cores. It has certain speeds, so Suzanne can't get into her original car, but goes into the first car, which is now recharged, and now accepts her new presets, the presets that she likes, changes seat height, whatever, music, and off she goes, driving by wire, although I think she's imagining a steering wheel there. And the whole stack moves forward again. So here we are. So this is the rethinking of the stacked car. These are earlier iterations. And getting them to the smallest possible footprint. So starting with the smart car at 94 inches in length. And here's our stacked car. Whoops. So in its unarticulated form, it's the exact same size, more or less. So when it stands up to allow the driver for ingress or egress purposes to leave the realm of the car, it gets even smaller than a smart. And it's everything. There's no traditional dashboard or the usual things you find inside the car. It's intelligent. So it changes the whole way you deal with interior design of vehicles. And here's a group of them standing. And this canopy opens to protect the vehicle from the weather and from you to get in and out of it. And here's a series of cars that are not exactly for the city, but based on that same principle of soft car. How do we start selling these things to people? So we thought of the semiotic pulse of sneakers again. And in this case, superheroes, or I don't know, Michael Jordan. So we thought of the Michael Jordan version of the car that didn't exactly ask all the same relevant questions about environment, but really used the same technology to make these things fun to drive. It's mostly when people see these, they're like, well, there's a lot of robotic control. A lot of, I don't drive anymore. There's no fun in these frickin' city cars. So how do we put the fun back in the vehicle? So we said, okay, fine, we'll think of athlete cars. We'll give you cars that are fun and still soft and sleek and that ooze. So we imagine this vehicle is something like, an athlete car, but about more like agility or gracious movement, like skiing or dancing. And we thought of 2 drivers in tandem would be inside the canopy of the car and work together to drive. So we articulated this chassis with multiple degrees of freedom. For the engineers in the group, they might like something like this, but there's a traditional structure of the car is a brick on wheels, and then by adding in various pivot points, we can get the car to constantly be on the ground in all cases, dealing with cambering, turning, etc., with 8 degrees of freedom in what we're calling the H-frame. So here's one section of the car that I did, the Jordan car. This is one part that moves like a swarm. It's in separate parts, and it's connected. Think of 2 motorcycles strapped together, and you share your movement space with another driver. So this is the back view of the Jordan car, this H-type vehicle with fluidic muscle controls, which would be some of these things you can see here attaching to the wheels, super soft canopies, and then the seat fitted around the driver, and it map your motion of your body to how the car would like to move. There's another project called the wearable seat that Patrick's working on at the Media Lab. So there's a Gretzky version of this car. And you can see here's the seat and the driver inside the seat. And the seat is mapped to the driver's body. And it's fitted right into the vehicle. And then 2 seats are added together. There's a frame and festo muscles is what's doing most of the control, which is a fluidic muscle technology. And then here's an example of the Gretzky squid-like soft car, which is very fun to drive. In fact, I have a video of it moving, but it's possibly some danger of motion sickness. You don't have to go fast in a car that's moving with 8 degrees of freedom. It's 2 motorcycles strapped together. You're getting a lot of motion in this vehicle, and it's certainly fun to drive. We called it, in this case, another iteration, the G-Race, or graceful motion car. And here you can see the 2 pods of the car strapped together. I had a lot of fun making these designs, so you can check this one out. That's pretty cool. And this is sleeves, thinking of not so much shoe technology, but sports gear technology like football armament or whatever they call those pads. But yeah, it'd be the same kind of thought. And then finally in this section is more about human-powered mobility, in this case soft flotillas, James Bond-like flotillas that become river gyms that move on loops. So the human buttocks basically provides the energy to move these cars. It trickles down to a battery which supports the powertrain to move. And so there are people that can go to work every day and get a workout, and there are people that can just say, I'm not going to do that. I'm going to sit there and watch you work while I go to work. Depends who's got the moral right. And finally, the synthesis of a lot of these ideas, which is this combinatorial event of the skyscrapers, the city, mobility from clanky boxes and elevators to softer kind of elevators, skyscrapers, and cars. This is the first thoughts that I had done with Michael Sorkin's studio, rethinking this kind of condition in the World Trade Center years ago. So this is a multimodal station and thinking of these clusters of tall buildings and really starting to question the idea of how can we really change the core of the skyscraper. Ever since Otis, skyscrapers are always going vertically up and down. What can buildings that kiss or touch or link or bridge do to the core relationship? So this is this first kind of visioning of that. And then getting into the research work, which is, this is going to show you some serious slides, but it's design research is asking questions you don't know the answer to and ultimately leads to some serious mathematics. I'll go through it pretty quick, but we asked the question, what are tall buildings and what can we say about them in circulation? So it's a real case study here, not that anything else wasn't real, it's just a different kind of analysis. Only buildings that were above 30 stories and that had been through the rigor of construction that we concentrated on. So we looked at their circulatory systems and said we can say things like without a shadow of a doubt what the advantages are of certain geometries in section and profile for their circulatory systems, such as in relationship to the skin or in bridging. These are the not case study buildings, things that I really wanted to look at, but we decided are too hokey to kind of get into. Because we're in Boston, this one might be interesting. Up in the, how do I touch it? Up in this corner here is Gillette, the razor guy. He was thinking way back in the day of clusters of skyscrapers connected underneath one roof for housing in some commune-like thing. Like fantastic visionary. I don't know how razors got into his world, but which is great. So we looked at the core relationship to daylight relationship, and what I can say about that. I'm not going to get into it entirely, but one of the things is that through some basic math and some simple computation, I could say without a shadow of a doubt what the most desirable geometric shape is in plan for a circulatory system in a skyscraper, and that would be a rectangle roughly at 1 to 3. What this shows you is the dark space, or the space you can't light naturally. Natural daylight, of course, is more ecological for a skyscraper instead of using electrified illumination. And then in section, same studies looked at all sorts of sections, tapered versus extruded, all of them in relationship to moving the elevator up and down. And then what happens when you have more than one of these tall buildings. So there's clustering, bridging, or linking mobility between linear versions and field versions of skyscrapers. So mobility between skyscrapers and their relationships were important. We did 5 design case studies to prove our theories with different programs and in different parts of the world, from Singapore to New York, and tested our principles on super bridging and sky surfaces and the introduction of green technologies that would, for instance, in this case, the Con Edison site, the turbines would provide about 10% of the needed to power these buildings. That would be sold back to the municipal grid. That was the advantage of bridging, would be in the cross bracing here. And then upper story views. And 5 benefits of bridging. Things like maintenance, rerouting of, for instance, if your air conditioning went out in one building, a bridge helps you reservice it. Diffuse structuring and lateral loading, it's an advantage. Safety assurance. Imagine if the World Trade Centers were bridged. And then what would be the frequency of bridging those buildings? So who would design for that, right? What would be the most efficient frequency of bridging in the Twin Towers? And then how long would it take them to fall down if they were bridged? And why didn't we bridge them in the first place? Well, certainly would have stood up depending on the frequency, and there's thresholds that describe that. This is using a structural technique called the diagrid, which is about 30% less steel in bridging. All of it dealing with circulation, then looking at elevators, express elevators, zoned elevators in relationship to bridging, drawing the plans and the details of those things, then diagrid systems. Here, this is the Freedom Tower, and this is Battery Park, rethought of the same FAR, but in this case with bridge skyscrapers. And then thinking of elevators that are a little more ecological because they skip stop. So instead of stopping on every floor, you go up one or go down one, or go up 2 and go down 1, and what are the efficiency gains and such things. All these lead up to some fantastic visions of what we're thinking the future skyscraper would be, but this research in and of itself is useful. Here's an armature that describes bridging in relationship to skip-stop elevatoring, and a housing solution for that, microclusters, vertical neighborhoods, and then bridge buildings based on elevator armatures. And then taking these ideas, efficiencies in circulation and ecological circulation and bridging, to Gehry's office and his massive project in Brooklyn, which was, I think, 16 skyscrapers in Brooklyn Atlantic Yards that were going to be connected to the subway, connected to each other, bridged all around the New Jersey Nets, or New York Nets now, arena, and rethinking skyscrapers. Now, Frank's office, we weren't concerned with ecology. I think I have to be rather straight about that. That I think that he's a formal-driven kind of individual. It's more sculpture than it is dealing, for instance, with the maximum amount of daylight you can get in one of his skyscrapers, which is really important to me. And working and consulting with him, I think he was just more interested in its aesthetic. Not to say that that's not important. It's just difference in concerns, and a pretty important one. So here's a view of Atlantic Yards, a cluster of skyscrapers connected about the 8th story, wrapped around a basketball arena in Brooklyn, and was terribly just anti-ecological. It's not an issue. It's just its sculptural form, and personally, I'm excited by it. But for instance, the 8th story sky lobby, there's not a building ever constructed on Earth that's bridged or has a sky lobby on the 8th story. It's completely inefficient. So that was one of the things that we were able to argue about, but ultimately I think it wasn't really a concern. So these last slides here are a project I've done with my partner in OJ Studio, which is, well, what if mobility equals space? What if cars equal elevators, and elevators are part of skyscraper clusters? What's the future view of the city? And we took on this challenge for a competition for the skyscraper for 2050. And our solution was what we called peristalsity, or using fluidic muscles or some level of pneumatics integrated. We'd say the elevator is your space, and you move in an intelligent field of elevators slowly up and down inside a cluster building on an armature. So this is the pods inside the elevator, is about 4 stories of elevator space. So you don't get out of an elevator into a space. You are always occupying the elevator, slowly moving up and down to account for light, air, natural ventilation, etc., views that you would need. This is the muscle skinning system of that. This is a diagram of contracting cores and the interstitial spaces with the fluidic muscles that allow this thing to be swallowed up and down. This is a movie, rather fast, kind of showing you the relationship of these super soft elevators. This is just a future proposition, because the previous facts give you stuff that's what's called, inherent buildability. This is off-the-shelf stuff that works. This is what I would call heroic feats of architecture, which is, let's think of something in the future. I give you both. And the final slide here is this peristalsity, these clusters of super soft elevators moving up and down vertically to ascend to a sky surface on the top. And these are the conclusions from getting the energy challenge to inherent visionability for this new field that we're looking at, eco-transology, and then the social aspects and linkages, or the integrated approaches. And I acknowledge a lot of these folks and engineers that worked on these projects with me. Thanks very much, and so I guess we had some time for questions. Sure, yeah.
I'm just curious about the rest of this competition for 2050 and whether there were any other drawings that you thought were as interesting, and what were the other themes that were pulled out. How many people are sort of thinking from cars to elevators to buildings? And then the second part of the question is, where do you see the most interesting design thinking for the future happening? Is it around buildings? Is it around vehicles, or the mixture?
I guess I'll take the second question first. I think the most interesting thing we can do is getting together like this, and the meeting of the minds is perfect. Powwows, small or big, of like-minded individuals. I mean, essentially I'm preaching to the choir. I would think most people here are interested in sustainability or ecology and mobility. I think it happens right here. These kinds of dialogues and presentations and learning from one another is paramount to something like this. I also think that it should become a pedagogy, that we're ready to put this in schools at multiple levels, from maybe not starting in high school all through the collegiate level, and have this as a profession of thought, where you just don't learn engineering and then you get out of school and you meet everybody else and say, well, we got to talk more. You actually do it all, or do as much as you can of each, and concentrate particularly, let's just say, here on transportation. But you just don't learn how to get, let's say, if you're statistician, trains from A to B on time, right? Obviously, logistics and planners who do this kind of work are intelligent people, but they would never say or stand up in their office and say, you know what, the trains get to A to B, they get there on time, but I'm going to pick up my train and I'm going to make it into a soft train and redesign the train, and because I desire to do that. Just like architects don't sit around and say, well, frickin' cars are always a problem, I'm going to redesign the car. I think that it's time that these solution spaces become involved in the pedagogy of all of these various disciplines. That's why we're working on this field, transology and eco-transology, to do something like that. The first part of your question, as far as other designs about the future, there's a lot of neat designs. Neat being the operative word, kind of slightly boring. They concentrated a lot, no offense to structural people, but they're all about structure. I do not care so much about structure as the focus of the other most important part of the skyscraper, Otis's contribution, or the elevator braking, moving, mobility, circulation. So I think we really, just from the very beginning, our point of departure was about circulation in skyscrapers, which is a vastly different approach than having structure. And, there's moving structures and kinetic structures and performative structures and skins. I think we touch the right pulse by thinking about circulation, and then its connectivity into the city. I think the biggest answer to a really sustainable skyscraper is the pill, right? I think as a topology, the building itself is just, well, it's a waste. Not a waste, but it's only there because of population. We have so many people, land prices are X amount of dollars, we start doing what's called sprung. Instead of spreading out and sprawl, we're going up vertically. I think if we had less people, there'd be less reasons to have things at 60, 70, 80 stories, or the world's tallest ecological building, which sends a lot of mixed messages. That might be the... Does that help? Sorry.
Young man, you are very brilliant, very bright. Allison,
Thanks.
I want to thank you very much for inviting this gentleman here.
Thanks.
I am impressed. I have a daughter who's an architect. I'd like you to meet her. But anyway, your concept on those vehicles, personal vehicles, I believe will be your most successful venture you'll ever make, sir.
Oh, thanks.
It should work and it will work. The buildings, well, in the science world, we have a famous saying, failure is the mother of success. I hope you will succeed, but it's going to take a little more trials and tribulation before you get to that concept. But the cars are amazing concept.
Thanks.
When do you plan to produce these?
Well, at the Smart Cities Group, we're working on a design to come out in November. There's sort of some discussion on whether we should introduce this vehicle in Detroit at the big motor show, or is this something that should go to a gallery space more as art, or is this something that should travel from university to university? So it's kind of tough where we want to place it. And another issue is that it's hard for us to settle on a form. I mean, I just showed you maybe 10 or 15 of these designs. We're never really satisfied with the final image, let alone built product of this vehicle. So it's kind of rough. The undergrads have something called the Green Congress, and they're fantastic. In about 9 weeks, they had, it was like 20 universities from all over the world build cars at MIT in the Aero Astro Lab. They built 5 different cars with 5 different powertrains, from human-powered to hybrid, an attempt at fuel cell. And they built a whole car from scratch. It's just great to be around there to see that kind of oomph. Unfortunately, at the end of the day, they had an artifact, and it was it was a car. It was an image of a car and an object, and it's exciting for a few moments, but in the zeitgeist or the hearts and minds of everyone, after some time it seems to lose its cadence, its original power. So it's I think for me it's going to be largely an academic pursuit, and the record and registration of all of these designs over time, to constantly record the different ideations, the different iterations of these vehicles, and what we can say benefit and constraint-wise of these cars, instead of just having one final vehicle being the ultimate answer, or anything that's an ultimate answer, is kind of tough. But we have to produce one, and so we've fought and a lot of swashbuckling, and so something's coming out. Yeah. Next question.
I don't know if your designs are going to be at next weekend at Alt Wheel, but if not, can they be? Blown up big and be part of Alt Wheel next weekend?
Yeah, I've been talking with Allison about giving posters, and yeah, absolutely. I mean, certainly. It's just a matter of the size and print and UV radiation, getting rid of the images in like a couple of days of sunshine. They're more for interior. I don't know, what are we going to put a tent up and something? But absolutely, we'll have more offered a year ago to contribute the designs. Right.
Should we take just one more?
Sure, yeah.
You jumped to wheels, but there are lots of other ways of moving humans around.
Yeah.
Can you talk about? There's maglev. There's all kinds of other options. Can you describe? You didn't talk about kind of how you got to that stage.
Yeah. Yeah, I've got a great diagram that shows, canals and waterways and freight transit, ocean liners, escalators, people movers, the Paris Exposition in 1908 with, moving sidewalks. I showed some brief images of moving carts and sidewalk transportation, things like that. Eventually, for the sake of research, in time, concentrated mobility in the car, or some notion of a computer that moves at a certain scale, which would be about 2 bodies or 2 humans and some storage space, and the minimal footprint that we could possibly have. And then I guess the elevator would be the other kind of strong, really hard look in the research, because I think. There's all sorts of cruel spaces you can think of in mobility, like toll booths. Imagine a toll booth worker is like 50,000 people pass by in one day. It's like, how you doing? And next guy, how you doing? And elevators too, being kind of these cruel spaces. You have to share things, and if you don't look at the guy next to you, and go up. Sometimes say hello to the guy next to you who thinks you're weird. We really concentrated. In the space of the car. I think that was the task at hand. But we certainly thought a lot about all other sorts of advancing human mobility. Things like the Segway, where, sure, why did the Segway work? Why did it not work? It made some really strong claims on how it redesigned cities around Segways. We found it, for instance, with the Segway, was an economic factor. The technology was just too expensive. And not only that, it was just too heavy, and there's probably some other experts here that can tell me all about the Segway, but an 80-pound vehicle it's too heavy to carry up and down stairs to store at home, so where do you keep these things? How do you garage these things? And more importantly, how do you share the space of the city with a Segway, right? A Segway, you're not comfortable walking in the same hallway with the Segway spinning about, and I don't think people on Segways are comfortable with Hummers driving next to you. And the thing about the Segway is it's not smart. Right? It doesn't talk to the Hummer, and it certainly doesn't detect other, dogs or people. So maybe a more intelligent Segway would be where we were concentrating in. And it was bringing in some of the powers and skill sets of the group at the Smart Cities group, the Media Lab. We're in things like, these skills were based in communications and signaling. So we certainly thought of mobility not so limited just to the car, but we did concentrate in the car. But again, the dictum of form follows frequency, that communication that's almost invisible between vehicles, is our way to go in a lot of cases. So, maglev is fantastic. There's some in that matrix I was showing future cities with maglev stuff. But since I've been a kid, since my father's been a kid, and he's 78 years old. That popular science said that magnetic levitation trains were going to change the world, and that was in the 50s. There's 1 or 2 in operation. Not that it's a bad technology, but we're thinking of things that are off the shelf, available right now, that we can put together in a lab with 10 people, and sell, and be pretty cheap. So these autonomous, intelligent wheels that are more about networks and signaling and talking with RFID tags, which are, less than 5 cents a piece, are important. Here, final statement. Think of a network city, and not a netlev city, but a network city where parking meters are intelligent. So your parking meters can say, I'm available, and tell the municipal grid. And everyone driving around looking for parking can say, there's a parking meter there. It's available. I'm going to park there, instead of this Zen method of parking where we drive around forever to guess where a space will appear. We know that space is available. And then we can have an economic model or a management model where you bid for the space. So you can say, I'm going to pay $5 because I really got to get to work. And someone else likes to say, no, I'm Trump. I'm going to pay $20 and take the space. But then when there's no one around, right, there's no demand, you park for free. And you know where that parking is. Now, it doesn't mean that there's some false social justice equation there where Donald Trump always wins out. But road pricing is, pretty ubiquitous, especially in London. So the bottom line is that we can begin the talk by having vehicles talk. Okay, thanks very much. Thanks.
Mitch, thank you so much. I mean, we really couldn't ask for anything better. At Alt Wheels, the whole vision is kind of to expand people's vision of what's possible. And Mitch's idea, he explained to me that the sneaker car potentially, when it bumps, could actually, like, little lights go off, and it could be a really fun occasion, sort of like a social get to know you, rather than, a million bodies left on the road missing body parts. So we're just so exciting to have somebody thinking about this. Thank you very, very much. Really honored. And I love some of the questions. I think that it's just exciting to know that people aren't just looking purely at cost, at what's commercially possible. I mean, so much of yesterday's discussions get limited by our current infrastructure and saying, okay, given that we have all these gas stations, how do we get vehicles that interface with those, rather than saying, well, wait, what were we trying to do here in the first place? And, how do we go back to first principles and mobility and thinking about moving freight and bodies and how to do that in a socially friendly way rather than in a hostile metal, this is my plate kind of way. So anyway, thank you so much for that.